Okay, ready? Do you remember what is this? So this is across a period. This is group one, group three. Phosphorus is group five, group six, and then this is group 18, 16, 15, 13, right now. This is across a period like this. So if you go across a period, this is a metal. This one is non-metal. Do you remember? Okay. And then metal can react with oxygen is called a metal oxide. Metal oxides for metal oxides are basic. You know, remember what's basic? Lah? Base means can neutralize acid. Okay. Non-metal oxides are acidic. That means they can neutralize alkali. But aluminium oxide is the only one that you learn that is amphoteric. What is amphoteric? That means can react with both acid and base. Can react with both acid and alkali. Okay. What is the meaning of proton number? The number of protons in the nucleus of an atom. Okay. How many protons they are? That's proton number. Okay. Write down the electron. Okay, this one you don't know. This one you don't can't remember. It's okay. This one you don't know. I'm gonna sit down and cry. If you cannot write 286, I'm gonna sit down and cry. Okay. State the group of aluminium. So also you don't know. I'm also gonna sit down and cry. Aluminium is group 13. Why? Three valence electrons, right? Correct. Does it have three valence electrons? Yeah. Elements in period 3 form basic oxides. Amphoteric oxides or acidic oxide while reacting with oxygen. Choose the one that is acidic. Okay, I just told you. Which one is acidic? Huh? P2O5, SO2. Non-metal oxide. Amphoteric only one. Aluminium oxide. Basic oxide is which one? Sodium oxide. Okay? Do you understand? Do you remember? Does this all look very familiar to you? Are you having flashbacks? Yeah. Okay, good. Which one? Do you know what's amphoteric or not? Can react with both acid and base. Okay? Ah. Why argon does not form? Argon has how many? It has a stable octet electron arrangement. It already has 8. It's not gonna gain or lose electron. Already has achieved stable octet electron arrangement. So cannot gain or lose electrons. Or cannot react with any other compound. Neon is another element that's located in the same group as argon. State the use of neon in daily life for advertisement lights. Remember neon lights? Okay. Wait, is it all coming back to you now?
Yes.
Your Hari Raya, you eat too much rendang, is it? Okay, look at question 4. Okay, as you go across a group, a period, sorry, go across a period from 281 to 288, it gets smaller. It gets smaller because the nucleus is stronger or weaker. The nucleus is stronger or weaker.
Good. That's all.
Stronger because from positive 11, it becomes positive 18. Which period are the elements placed? Answer me. 3, 2, 1. Thank you. All right. State the element that exists is diatomic. Who is diatomic? Okay, read the question. Read the question. I give you 5 minutes. Quick, quick, quick. You must be able to answer. These are the type of exam questions that come out. Okay, can? Okay. Quickly do 4 and 5. Quickly do. Okay, element that exists is diatomic chlorine because it's Cl2, right? Element that exists is monoatomic argon. Which element can be found as amphoteric oxide? Aluminium. Correct? Okay. Used as a semiconductor, silicon. How do you know? I told you that day. Why electronegativity increases across the period? Ah, this is the one. Okay. So what happens? The what of the nucleus? Okay. Do you remember the explanation or not? Do you remember the explanation or not? All of them have 3 shells. 281, 282, 283, all the way to 288. Okay? But the nucleus of sodium is positive 11, but the nucleus of argon is positive 18. So the nucleus becomes more electropositive, right or not? So it's positive 11 and it's pulling in 3 shells. Positive 18 is also pulling in 3 shells. So who will pull stronger? Positive 18 or positive 11? Positive 18 lah. Correct 吗？如果它11公斤，你18公斤，你吸收谁比较重？18公斤啦，right or not? Okay. So the nucleus of the atom becomes more electropositive across the period. The attractive forces between nucleus and valence electrons become stronger. Okay? Okay? Can sodium burns in oxygen. Sodium burns in oxygen, becomes sodium oxide. Remember, group 1 is called alkali metal. They are called alkali metal because they dissolve in water to become alkali. So if sodium oxide dissolve in water, it becomes alkali. NaOH. Do you remember? Okay, just pretend you remember, okay? So what's the color of litmus paper when it's placed in solution? Blue. Okay, put lots of hearts around it so you remember. Can? Can? Okay. T and R. Okay, so this one, T and TQ and R are located in the same group periodic table. State the group of the elements. Group what? One reason for your answer, one valence electron. Correct? Easy, yeah? Okay. Q is located, become T and R and write the electron arrangement. Okay, if you don't know this also, we can start and cry 281. Okay, got it? Why is element Q more reactive than element T? Ah, same answer. Remember, now it's 2, 1, 2, 8, 1. 2881. So the distance between nucleus and valence electron is nearer or further away? Further away. So the attractive forces is stronger or weaker? Weaker. So 这个比较容易跑掉啦. Get it? Can you understand? So what do you say? The atomic size increases or the atomic radius increases. Okay? Electron Q. Okay, so the atomic radius of Q is bigger. Okay, the distance so the attractive forces between of Q2 valence electron weaker. So easier to release electrons. Easier for Q.
Teacher.
Hmm?
So it means that if the electron arrangement is like if the electron arrangement is bigger than Z, it's more easier to look electron that it will become more explosive.
Yes. Yes, correct. But then group 7 is the other way around because group 7 you're trying to gain. So group 7 going up is more reactive. Okay? Group 7 is terbalik, group 17 is terbalik. Group 17, fluorine is the most reactive because fluorine wants to gain electron. Group 1 is want to lose electron. All right? Okay, write a balanced equation. Uh, so R with fluorine becomes RCl. Do you know why? Do you know why? Cannot write RCl2. Okay? All right, calculate the mole mass of the product form. Okay, so if this one is 0.1, how much is this? Is it also 0.1?
Yes.
Yes. Okay, so 0.1 multiply R plus CL. 39 plus 35.5 is 37.5. It's 74.5. So 0.1. Do you know why 0.1? Small cell. So 7.44 grams. Do you understand?
17.5.
Eh, my goodness. I copied from here to here also. I was looking at this and this at the same time. All right, ready? Okay. Write the electron arrangement for that. Okay, what's your answer for this and this? What's your answer? 2, 8. And this one is 2, 8. Fall asleep really. Faster, faster, faster. 2, 8. 2, 8. Wait, 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 faster.
27.
2, 8, 7 is chlorine atom. Are you guys serious? Chlorine atom is 2, 8, 7 in order to form chloride ion. They want to form full outer shell, receive one or lose one. So become 2, 8. 8. Oh. All right. Write the chemical equation between chlorine gas and sodium hydroxide. So chlorine and sodium hydroxide. It forms something. Okay, this this is not an alkali. It's not alkali, it's not acid, it's chlorine gas. But chlorine gas, it can dissolve in water to form sodium hydroxide. Okay? Can. Sorry, chlorine gas can dissolve in water to form acidic. Okay, so what we do is it forms sodium chlorate and water. Can you balance this equation? Are you done? Okay, sorry, it forms sodium, and sorry, it forms one more, NaCl. Okay? So how do you balance this equation? Okay, just add the 2 in front of NaOH. Okay? Okay? Compare the attractive forces in the nuclear of valence electron in chlorine and bromine atom and explain the respective. Okay, this is exactly what we learned just now. Do you remember? So it's just terbalik. What are you going to write for 6 marks? Who is more reactive, chlorine or bromine? Chlorine more reactive. Then you copy the same as just now. So the blah 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 blah. Then you just change the words. Okay, so you literally where did it go? You literally write this. You just change the words. Okay, more reactive than bromine. So how do you change? The atomic radius of bromine is bigger than chlorine. The distance between the nucleus of bromine is and valence electron is further. Okay. The attractive forces between the nucleus of bromine. Or you can do the other way around. Towards valence electron is weaker. So it's easier or harder? Harder for bromine to gain or lose electron. Gain. Do you understand?
Wait, so it means that the last like the bottom one is the hardest to gain electron.
Yes, correct. Easiest to lose, hardest to gain. But group 17, I want to gain. Group 17, I want to gain. Group 1, I want to throw. Understand not? But the concept is exactly the same. Get it? And then, okay, 这个是六分嘛，你可以讲什么？Chlorine 有3个 shell, bromine 有4个 shell. Understand not? So you just add one more sentence. Chlorine, 3 shells. In 4 shells. Okay, ready? Do you understand? Yes. Okay, now diagram 6.3 shows the setup apparatus for the investigation of the reactions between bromine and iron bowl. Okay, what is the function of the filter funnel in this experiment? Okay, so now 这个是 gas 嘛，啊，sorry, I cannot see. Oh, liquid bromine. Okay, I want the bromine to react, okay, with the sodium hydroxide, right? Okay, bromine and iron, sorry. So what happens is, if there's any extra gas, do I want the gas to go out anywhere? Is bromine gas safe or not safe? Not safe. Okay, so 这样放小一点，看不到。Okay, okay, so bromine gas is not safe. Okay, so what happens here is, 那个 bromine react with the iron, but can you guarantee 全部 bromine react 到完? Can you guarantee? No. So what happens is, uh, Okay, what happens is the extra one, if I just let it go everywhere, it will dissolve. But this one, will it dissolve inside this? Yes. Just now we just wrote, right? Br2 plus NaOH. It will dissolve to become neutral. NaOBr plus H2O plus NaBr. Same concept. Do you understand? Okay. So what happens is that's why we have the sodium hydroxide. But why do we have the funnel? Will this increase or decrease the surface area? Increase. So will it ensure all the excess bromine gas dissolves in the sodium hydroxide? Yes. Can you understand? It's for safety. Okay. To increase surface area to ensure excess bromine gas, bromine gas dissolves in NaOH. You don't want it everywhere. You want it to dissolve inside. Okay, look at the next question. What do you think is the answer? What state two observations that can see? Okay, when you're reacting, do you think the iron wool will shine brightly? Yes. Okay, so it's like this. I show you something, right? So what do you see? The iron wool glows. Okay, and then after it's left over, after you finish reacting, it becomes iron 3 bromide. Iron 3 is a brown powder. Okay, a brown powder will form, or brown solid forms. Okay, can iron wool glows because the iron wool is reacting. Okay, all right. Describe and write chemical equations for the reaction occurs in A and B. So A is, okay, now what you need to understand is when it reacts with halogen, it always forms iron 3. It will always form iron 3. Do you know the difference between iron 3 and iron 2? Yes, teacher, I know because you taught me and I remember everything you taught me. Okay? When it reacts with halogen, it forms iron 3. Iron 3 is Fe3 plus. Br is Br negative. Do you remember? Okay, so you just have to balance the equation. That's here. Okay, then region B is same as just now. I just told you, right? It's the excess bromine react with NaOH. Who did not say? So it forms NaBr, NaOBr, and H2O. Balance equation 2. Can? Do you understand? Did you write it down? Go do something. Pick a man. Okay, ready. Uh, okay, no, no, no. Okay, can you all try and do question 7? Try and do question 7. Oxide of X dissolve in sodium hydroxide to form a colorless solution. Okay, oxide of X dissolve in hydrochloric acid to form a colorless solution. That means oxide of X, does it react with alkali? Does it react with acid? Yes. So what do you think is amphoteric acid or base? Amphoteric. So this one is amphoteric. Okay, oxide of Y is insoluble. It doesn't react with sodium hydroxide. So it is a basic oxide. Okay, it doesn't react with base, but it reacts with acid. So itself is base lah. So then this one dissolves in, but doesn't react with it. So what is this? Acidic. Get it? Okay. Arrange in order in decreasing atomic size. That means who is at the left? It's metal and then non-metal, right? Who is at the left? Who is here? What's your Y first? 你想啦 X. Huh, no.
Why?
Why? The aluminium oxide group 3 what? Right not? So Y and then X and then the non-metal is Z. Get it or not? The non-metal is acidic. This one is the non-metal. This one is the group 3, group 13 aluminium, and this one is the group 1 or 2. Get it? Okay? So, but then you're supposed to arrange in decreasing atomic size. 所以最小 who is the smallest? Z smallest. So it's exactly the way it's written. Okay? So just the name of X. X oxide, oxide of Y and oxide of Z. Okay? So this one is aluminium oxide. Aluminium oxide. What am I supposed to write? Okay, I write what it's X aluminium oxide. And then oxide of Y is who? You can say sodium oxide. And then Z, you can write sulfur dioxide. Okay? Can? All right. Write the chemical equation between oxide of Y and hydrochloric acid. Oxide of Y is sodium oxide and hydrochloric acid. Acid and base, you get salt and water. Okay? Can? All right. Okay. Uh, okay, this one we do later. Are you done? Done, done, done. Okay. Can you all please put the next one? What is meant by empirical formula? Formula that shows the simplest ratio of atoms of an element in a compound. Do you know that? Now you know that. Okay. Okay, ready? Calculate the mass of magnesium that have reacted. Okay, this this is mass of crucible. This mass of crucible and lid, and so you take this minus this. Do you know that? Okay, 28.0 minus 26.4. How much you get? 2.4 grams. Okay, can? That's the mass of oxygen. Magnesium, this is oxygen. Magnesium is 26.4 minus 24. How much you get? Huh? 2.4. Is this also 2.4? Oh, 1.6. Do you get this? Yeah? Do you remember how to count? Okay, so magnesium, oxygen, mass over molar mass, mass over molar mass, 1 to 1, right? Empirical formula MgO. Chemical equation Mg plus O2 become MgO balance equation. 2, 2. Do you remember? Okay, this is the easy part. The calculation is the easy part. What happens is a few things happen. Your magnesium ribbon has to be cleaned with sandpaper. The reason is because is to remove the layer of oxide. There's a layer of oxide. You only want magnesium, you don't want magnesium oxide. Okay, and then when you're doing the experiment, you cannot just open it because magnesium oxide is a white powder, smoke. The smoke will come out. But you cannot just close it. If you close it, no oxygen can come in. Okay, it's open and closed to allow air to enter. OK，比如那个 magnesium 跟水 react，它里面是要跟 oxygen react 嘛，oxygen 用完了，你还要多 oxygen 进去嘛，知道吗？
你要把那个东西擦掉，就是我们的 remove 那个 oxide。
没有，那个是你还没有量，你放进去，你要放 magnesium 进去先。可是你的 magnesium 已经有肮脏的 magnesium oxide 在上面，你要量 magnesium 跟 oxygen react 啊，OK？How to determine all the magnesium is oxidized? How you know all react already?
until it become
No. 如果 I weigh 我这个24哦24.0哦，24.4，26.4，我烧27.8，做一次罢了，可以吗？不可以，我还要去微多一次，变成27.9，可以吗？不可以，我再微多一次，28.0，可以吗？不可以。老师，这个答案是28.0，好啦，I know 这是答案吗？What do you do？我就去烧多一次，去称多一次，28.0。Now constant already, that means no more reaction. Understand? How do you put this in words? You reheat and reweigh until a constant mass is reached. Understand? That means you repeat and repeat until a constant mass is reached. Okay, metal X is placed below hydrogen in the reactivity series. You are required to carry out experiment to determine the empirical formula of metal X. Okay, so like this, um, this is hydrogen. Okay, metals that are above are usually group 1, group 2, group 13. Metals that are below are usually the transition metals. Okay, can so if it's higher, you can use the crucible. If it's lower, you don't use the crucible. You use the one, this method. Okay? The reason is because here I know it's copper 2 oxide, 可能不是 leh. 可能是 copper 1 oxide, 可能是 copper 2 oxide. I don't know which one. Okay? So if I just heat up like that, put crucible and I heat up like that, 它可能 copper 1, 可能 copper 2, I don't know which one. 可能 mixture. Understand? So when it's below the reactivity series, if it's a transition metal, we don't use this way. Okay? Metal X is placed below hydrogen in the reactivity series. You're right. Can the apparatus setup use uh no, not really. Okay. Okay. There. One is the reaction is too slow. Number two is there might be more than one product form, more type of one, more than one type of oxide form. Okay. Okay, can. Okay, last one. Can you do this? This is the terbalik equation reaction. Okay, can you do this? Just do question 7. Sorry, question 6. Just do question 6. Okay, this one is the other way around. Just now is magnesium I make into magnesium oxide. This one is terbalik. Copper oxide I make into copper. Okay, now this is to make hydrogen. Okay, this is to make hydrogen. You will learn this later on, but I teach you how to write. Lah. Okay, acid and metal form salt and hydrogen gas. So this hydrogen gas will go here, and then here you heat up the copper 2 oxide. So the copper 2 oxide, what will happen is like this, the copper 2 oxide will react with hydrogen to form copper and water. Okay, can? Alright, so this is for the excess gas and water to go in. Lah. Alright, can I understand? What is the purpose of putting zinc granules to produce hydrogen gas? Okay. What is the function of the water in a boiling tube? The water to dissolve the hydrogen, excess hydrogen gas. Why? Why must dissolve? Because hydrogen gas is flammable. It will kaboom. How do you test for hydrogen gas? It pops, right? A little bit of hydrogen, a little bit of pop. A lot of hydrogen, then kaboom. Do you want it to kaboom?
Yes.
Yes, okay. It's a very interesting concept. Okay. Get it? Why must two hole stoppers be fitted into the boiling tube at the left side? One to allow the gas to enter, one to allow the air to leave to what? If if this one 关着，那个 air 可以，那个 gas 可以进去吗？不可以，因为 you need air pressure. Okay? All right. Outlet for gas. Outlet for gas. Okay. Or outlets for air to balance the air pressure. Okay. Okay, this one calculation. Oh, Allah, those one. What is the, did you get CUO? Please tell me you got CUO. Please one, you take copper. Okay, okay, I count for you. I hate count. So many zeros. Okay. So this one is copper is 3.4768 minus 3.4918. Wait, sorry. Copper is 3.4768 minus 3.4168. So 0.06. You got it? Oxygen, you take 3.4918 minus the one below, 3.4768. 0.015. Do you get it? Okay. This one 64, this one 15. 16. Oxygen is 16. So you get a ratio of OMG. Five. 0.0009375. So what's the ratio? 1 to 1. Okay. Why hydrogen is allowed to flow continuously? Okay, now what happens is like this. You don't let the hydrogen go here, go flow. Okay, this one is still hot. If this one is still hot, it will react with the air. Inside, it will react with the air, number one. Number two, if you don't flow it constantly and this thing is still hot, 那个水会进去，会进回去。Understand? This is called suck back because the pressure will, this one suddenly cold, the pressure will go down and then the water will suck back and then the test tube will crack. Get it? Okay, so there's two reasons. Okay, first of all, how do you ensure all the oxides reacted? Okay, so it reaches a constant mass is achieved. So reweigh, reheat until constant mass. To cool to allow the copper to cool down. Can empirical formula magnesium? No, why not? Magnesium is more reactive. The one above cannot, is more reactive than hydrogen, not than copper. Okay? Oh, yeah, that's the answer. All right. Okay, can Do you think you can finish all this as homework for your to prepare for your exam? Can or not? 你们不要直接不要做啦，不要做很难。You cannot improve, It's not that much. Can you try and do?
For easy, yes.
Okay.